Okay, let's quickly review over intermolecular forces. These are not bonds. So a chemical bond is very strong. It's hard to break. So these are weaker than bonds. So the first one is one that you've heard about probably in most of your science classes, and it's called hydrogen bonds. We're going to use the term bond loosely. It is the stronger of the intermolecular forces, and basically it's just this bond that water molecules have. So it's for water, and it's what gives water its properties. So like adhesion, cohesion, the ability to form droplets, capillary action, all the properties of water that you know. And what it is, water molecules basically act like little magnets. So you have one side that's more electronegative and one side that's more electropositive. And these positives and negatives have a little force of attraction between them, which makes the molecules stick together. So they stick together. So it's like magnets. So this is a strong intermolecular force. That's why they termed it hydrogen bonds, because it is a stronger one. And it is important for water. It's what gives water its shape. It's what makes the rare property of water, the solid, being able to float on top of a liquid, because it makes it less dense because of the arrangement of these molecules because of the hydrogen bonds. Next one is dipole. So a dipole force is basically the same thing. It's between two polar molecules. Polar molecules, like the polar covalent bonds, is what we're talking about. And it's exactly what it says, two poles, two poles. So you have a side that's more electropositive and one that's more electronegative. And the positives and negatives will line up and you have a little force of attraction between them. And then the last one is a London dispersion force. And this has got to, I'm just going to draw a rough sketch of an atom. Little Jimmy Neutron looking atoms here. This has to do with the movement of electrons. So this is based on the chance that at any given point, all the electrons from the atom can end up on one side of it. If they end up on that side, then that side becomes more negative. The other side becomes more positive. So there's a weak, very quick little force of attraction between those molecules. So it is quick, it is very short-lived. And that's pretty much the summary of intermolecular forces.